Interference. Interference is the outcome of superposition of waves. First of all, we should know what is the superpositions technique or the methodology for superimposing the waves. Superposition means simply combination of two waves. And when the waves are traveling, the particle is not getting displaced, it is simply oscillating around its mean position. Suppose some wave is going this way, it is going horizontally towards east, then the waves are producing this way horizontal. Suppose some other wave is going towards north, then it will be proceeding this way. Ultimately, at the juncture, both the waves will meet, you might say, they will interact, you might say, they will collide, you might say, they will superimpose on each other. You see, when two materials strike or collide or make an impact with each other, like two bikers on some crossing, suppose they collide, then their geography becomes history. Ultimately, they are going to change their geography into history. Why? Because they will not remain as usual. If accident has actually taken place, the shape will be D-shaped. This is quite unusual with the waves. When waves superimpose with each other, their path remains quite unchanged. Suppose some wave was going due east, it will continue. The wave that was going due north, it will continue due north. Only the thing is that at the point of junction, some changes are likely to take place with the amplitude of the oscillating particle at that very moment. Suppose one particle came across wave going due east, other particle, same particle came across another wave going due north. The resultant displacement of that particle is going to be the sum of individual displacement produced by both the component waves. This is what we call principle of superposition. More simpler way for expressing this principle is y equal to y1 plus y2. What we want to convey here is that y1, y2 are the displacement that are possible by both the waves. For the resultant, we are going to sum up. But while summing up, we have to consider whether the two waves are in helping mode or they are in opposing mode. If both the waves are this way, you see, then you would say they are in the same phase and they are going to help each other. The resultant displacement will increase. The result is going to be like this. Now, suppose the other wave is quite opposite to the first one, then what is going to happen is that they will counteract, then they will try to minimize their amplitude. In this case, it is going to be y1 minus y2, and suppose both are having equal amplitude in opposite phase, then the resultant is going to be 0. This is what the principle of superposition actually is. So, with the principle of superposition, we came across this important fact that when two waves superimpose, something different is likely to happen. Here we would try to elaborate three processes: stationary waves, beats and interference, because of this principle of superposition. In fact, interference we are going to study, but stationary waves already we have covered. Stationary wave means the medium is bounded, this is tightened or the fixed ending, and wave is produced from one end, this proceeds in one particular direction, wave is reflected from this fixed end. Now, you are having two waves, the source is here, waves are regularly produced. So, waves are continuously moving in opposite direction, the reflected wave and the original wave, they will superimpose and stationary waves are produced, that we have covered. Here, the process of interference and beats, for the phenomena of beat to take place, the two superimposing waves must be having different frequency. And this is not a point of concern right now for us. We are going into detail of interference. Interference, what happens? Two waves should superimpose on each other, and the condition is the waves must be coherent. You see, interference could take place with mechanical and non-mechanical both the waves. Interference takes place in light also along with the sound. Here we are focusing on interference in sound.